The question for today is painting a grid with three different colors. You are given two integers m and n. Consider an m by n grid where each cell is initially white. You can paint each cell red, green, or blue. All cells must be painted. Return the number of ways to color the grid with no two adjacent cells having the same color. Since the answer can be very large, return it modulo 10 to the power 9 plus 7. So what it is saying is, look at example 1, m1 and 1. So let us consider it our own. So there, suppose that this is m1 n1, length, height, or length, breadth, whatever it is, all is 1. So when it is 1, we can have three possible coloring. Either it can be colored red, or it can be colored green, or it can be colored blue. So initial position of the grid is this. Initial position of 1 by 1 grid is this. After painting, it has three possibilities: 1, 2, and 3. So it is asking that return the number of ways, it is asking that return the number of ways to color the grid with no two adjacent cells having the same color. Since the answer can be okay, so I just returned the number of ways. So so there are three ways from which this cell can be painted. Alright, now this was a smaller example. We cannot see here what happened when adjacent cells comes. Let us take a wider example to study it. So let us say that we have a 4 into 4 4 by 4 grid. Okay, so initially, okay, just let me make it 4 by 4 grid quickly. Let us say we have a 4 by 4 grid, and initially it is painted white, right? So let us remove this as we will need space. So let us say we have here m is equal to 2, comma, n is equal to 2. Right, let us see what happens here at this time. So we have a 2 by 2 grid, let us say this, and initially all are painted white, right? So let us say that we have this grid, okay, initially, right? Let us see how dynamic programming works here. So we have this grid initially, 2 by 2 grid, 2 length, 2 height, right? 2 by 2 grid we have. Next, what we have to do, let us understand what question is saying. We were provided with 3 colored cells, right? Let me make all this initially white so that it is easier to understand. So we were having 3, and suppose this into copy paste. So this can be divided into 3 equal part, right? 1, 2 and 3. Now what I am trying to say is, the first cell can either be red, or the first cell can either be green, or the first cell can either be blue, right? So we said that the first cell can either be red, let us denote it by 0, or the first cell can either be green, or the first cell can either be blue. This is what we met the statement, and we are trying to color the complete grid. Let us see what is the solution. Let us say that randomly we have picked 1. We can pick anything. I am just picking it 1 for the first time. So what I am saying is, now I need to say what happens next. So I have this, I need to say, look at the possibilities for the next cell. So I say that right, the next cell can either be red, or the next cell can either be green, or the next cell can either be blue, right? We are trying to paint a 2 by 2 grid, but here the problem is, in the question it was mentioned that we cannot take 2 adjacent cells as same color, right? So from all the possibility that we get from here, we will discard this possibility. We cannot take this, so we will leave this here only. Now let us proceed and try to color the third cell. So for coloring the third cell, we have 1, we have 2, and we have 3, right? So for coloring the third cell, again we have 3 options. Either I can color it red, or I can color it green, or I can color it blue. right? But in the question it was mentioned that no two color can be of no two adjacent grid can be of same color, so we will discard this cell. Now what we will be doing is we'll be saying it 1, we will be saying it 2, and we will be saying it 3, right? So next what we will be doing, we have three options here. Either we can have red, which is 0, or we can have green, which is 1, or we can have blue, which is 2. Right, but we cannot have two adjacent cells with same color. We cannot paint two adjacent grid with the same color, so we discard this. Now we have come to a position we have this, we have this, and we have this. Again we can color it in three ways. We can color it either red, that is 0, or we can color it green, that is 1, or we can color it blue, that is 2. Among these three options, we will discard this, as red and red are adjacent cells, right? And we will discard this as blue and blue are adjacent, right? So now you can similarly complete each cells, but for now what I will be doing, I will be just calculating for 1. Since I am calculating for this at each level, I get a valid option here, right? I say that it will return 1. Okay, sorry, I say that it will return 1. Yes, it will return 1 from here, it will return 1 from here, and it will return 1 from here. So the total for this cell I get is 2, and the total for this cell I get is 1. So when I will add 2, I will get 3 for this, right? Similarly, I will get 3 for this, and when we add this both, I will get 6 for this, right? Similarly, for this I will get a 6. Since this is a 2 by 2 matrix, you should complete it and see what happens for the better clarity. Okay, and this will also return 6. So the total that I get here, the number of ways the white 2 by 2 grid can be colored is 6 plus 6 plus 6, that is 18 ways, right? So this 18 is the answer. Right. Now let us see how we can do it in coding ways. So we will do it step by step. The first step would be we will take care that no two color in the row is same, right? Second, we will say that no two okay, so no two adjacent color in the no two adjacent colors in the row is same. As similarly, no two adjacent colors in the call is same. Third is row same, column same, and third is we need to count all the grids, right? We need to count all the valid combinations, right? Here's where DP will come into play for counting, right? So okay, now let us move to the coding part. So what I will be doing, I will be just making everything small so that we don't get lost these things. Okay, we can go and use it for our reference purposes. Right. So we have said this. Now yes, now what I am saying is okay. So let us move to the coding part. So let us say that no two adjacent columns are valid in so no two adjacent columns in the same row, in the row is same, right? And so for that we need to find something like this, like say that okay, we have all the possible ways here. We have 0 0, right? Means like this, 0 comma 0, 0 comma 1, 0 comma 2, 1 comma 0, 1 comma 1, 1 comma 2, and then we have 2 comma 0, 2 comma 1, and 2 comma 2. What this is representing is, this is representing each cell. So as here we have mentioned that this 0 1 is a 1 0 is a valid cell. So we will say here that 1 0 is a valid cell, 1 2 is a valid cell. You can see here that we have mentioned here 1 2 is a valid cell. So 1 2 is a valid cell, but 1 1 is not a valid cell. We have discarded it. So what we will be doing, we will be discarding 1 1 from here, like, right? Likewise we will see that same as 1 1 is discarded here, 0 0 would be discarded somewhere here, and 2 2 will be discarded somewhere here, because these are not valid rows. As we get same adjacent color in the same rows. So let us say that we have removed this and we have removed this, also we have removed this. So this is valid. We can map each of them, like this can be mapped to, say, like I have a convention that this is mapped to 1, this is mapped to 2, this is mapped to 3, likewise anything, right? So we have this. And now the second thing is the the second thing that we get is no two adjacent columns must be same. So for example, if we have 0 1 here, suppose we have 0 and 1 here, what we will be saying it, the adjacent columns to it must be, so let us say you have 0 1. So if it is 0 1 here, the adjacent column cannot be 0 2, at 0 0 is same. 1 0, yes, it can have. So the adjacent column can have 1 0, right? Now the second adjacent columns that can have 1 2. The next adjacent column that we can have 2 0. The next adjacent column that we can have is 2 1. No, because in case of 2 1, let us see here, in case of 2 1, 1 1 will become adjacent. So this is all the valid next row for 0 1. Now let us say that now we have moved to the next element, that is 0 2, 0 comma 2. So what we will be saying is, what are the adjacents for 0 2? For 0 2, 1 0, 0 comma 2. 1 comma 0 is a valid case, yes, because there is no adjustments. So 1 comma 0 is a valid case here. Now second is 1 comma 2, no, 2 will become same. 2 comma 0, yes, 2 comma 0 is a valid case here. And 2 comma 1, yes, 2 comma 1 is also a valid case here, right? So this, now again we move to the next adjacent, that is 1 comma 0, right? So similarly we will find the next adjacent, and likewise, right? So we will get an adjacency matrix for our, for the adjacent color in column, and we will get rows, adjacent color in rows, adjacent color in column, and then we will count everything in a DP, right? So somewhere if we get to path 1 and path 2, we can then calculate all the possible patterns by using a DP. We will put 1 1 1 1 at the last, and then we will increment our number by 1 once we see a valid pattern, and we will start adding everything else. So is it clear? If you have any doubt, then first complete this complete graph that we are using for understanding purposes, and still you have any doubt, then you can ask it in the comment section. Now let us move to the coding part, right? So let us say that mod is 10 to the power 9 plus 7, right? Then we have total patterns, which is equal to, since it is 3, it would be 3 to the power n, right? Now we will generate all valid row coloring, generate all valid row colorings, right? So we will have valid row patterns, right? And we will also map pattern to colors, right? This will be a ticked. Now we will do for loop for the row. So for pattern index in range, total patterns, or pattern index in range, total patterns. So you are getting here what I am doing, right? Total pattern is n is 2, so 3 to the power 9. Here you can see that the total pattern we get is 9. And what I am trying to do here, I am trying to run over each index here, like 0 0 0 1 0 2 1 0 0 2 2 0, likewise. So 0 0 0 1 0 2 1 0 1 1 1 2 3 2, sorry, 2 0 2 1 2 2, right? So I am going to run over all the valid index patterns, right? So what is here now? First we will define colors, then we will define temporary pattern index. Alright, then we will do for underscore in range m, right, range m, colors dot append temp mod 3 because we don't want anything greater than it, as there is only 3 colors, so it must be represented by this. And then we will say that temp is divided by 3, right? Now for this, if any color is same, if any color is same, so how color will be same? If any color I equal to if any color psi equal to color psi plus 1, in that case we will say that the color is same. So for each row, so row is m, so for each column, so for I in range m minus 1, right? So this will be, and if we get this condition that any of the adjacent color is same, then we will just say continue. Otherwise what we will be doing, we will be adding it to valid row pattern. We will be appending the pattern index to valid row pattern, right? And we will also add it to pattern to colors, pattern index, which is equal to tuple and tuple of colors, right? Now we have generated rows, correct? For okay, yes. So for each unique pattern, for each row, if any color is same, just continue, and if it is not the same, just return valid row pattern and pattern color. So that's how we get all the valid rows. Now step 2 is valid false. So how we will be doing it? We will say that compatible patterns the compatible patterns are right. Now next is valid row patterns, and so it will be upper row and for lower row, and then we have, if all of them are not equal, then only add, otherwise don't add. So if all, so here we will say for a comma b in zip, patterns to color, upper, patterns to cover, lower, right? If A is not equal to B, then only I need to append it to compatible patterns. Upper dot append lower, right? So this is, now we need to count, right? So count all the combinations that are valid. So for the first cell it will always be 1. Any pattern is always 1 for the first cell. Now what we are going to do, we are going to run it from the second row to end. Right, now we say that new DP is equal to default int. Right, now for priv pattern in count in dp dot items. Now for next pattern in compatible, compatible patterns previous pattern, right? Here we will say that new DP next pattern is equal to new DP next pattern count percentile mod, right? And then we say DP is equal to new DP, where we will say, yes, for here we will say DP is equal to new DP, and we will return here sum of run, and we are getting a error just for the, because I am going to submit it in yes. So let me go and see. Okay, so the code is 78%. structure, and let us see that what is the time and space complexity here. Okay, so this is order of m, 3 to the power m. This is order of n, and we have multiple complexities inside it. So if we will analyze the time complexity, we will get 3 to the power n plus something. That means it must be something more than 3 to the power n. The server is busy. So we get here 3 to the power 2m and something m into n, rows plus common into 3 to the power 2m, rows plus columns. We go here and analyze our so this is to the 3 to the power m, I know that, right? This is order of m. Now this is order of n. Is it saying order of, no, m. Okay, so this is quite a complex code, right? And even it take a very long time to complete it. So that's it, guys. That's it for today. Do like my video if you want to support my work. Thanks.